Hello everyone. Today I am going to discuss about the topic in refrigeration systems about air refrigeration system. What is air refrigeration cycle? Air refrigeration cycle systems belong to the general class of gas cycle refrigeration systems in which a gas is used as the working fluid. The gas it does not undergo any phase change during the cycle. Consequently, all the internal heat transfer processes are sensible heat transfer processes. Gas cycle refrigeration systems find applications in aircraft cabin cooling and also in the liquefaction of various gases. Air refrigeration cycle. Air is used as a working fluid. No changes of phase throughout. Heat carrying capacity per kg of air is very small compared with other refrigeration systems. High pressure air readily available in the aircraft. It has low equipment weight. It has four basic elements. It is compressor, heat exchanger, expander, and a refrigerator. It is divided into two types of system. One, it's an open system and another is closed system. In open system, the air used in the refrigerator is thrown outside into the atmosphere. In closed system, air used is recirculated. To increase COP, that is coefficient of performance, T2 temperature should be kept low, but it cannot be reduced below 25 degrees Celsius, which is atmospheric temperature. The temperature it should be kept high, but it cannot be increased above 0 degrees Celsius. It is the required temperature. Advantages of air refrigeration systems. As the air is easily available compared with other refrigerant, it is cheap. The air used is non-flammable, so there is no danger of fire as in ammonia machine. The weight of the air refrigeration system or tons of refrigeration is quite low compared with other refrigeration systems, which is one of the major causes selecting this system in aircraft. Here it is the diagram of the air refrigeration system or Bell-Coleman cycle or reversed Barrington cycle. In this, the refrigerant first passes through compressor and then it first passes through compressor and then to heat exchanger. In this, the low pressure changes to high pressure, and when it touches heat exchanger, the hot substance is converted to cold substance, and the refrigerant then passes through expander where the pressure is reduced, and this reduced vapor or air it then passes evaporator where the substance gets further cooled and it is absorbed and it gives a cooling effect. It is operated by a motor. Here it is the diagram of PV and TS, that is pressure, volume and temperature entropy. The components of the air refrigeration system is shown here. In this system, air is taken into the compressor from atmosphere and compressed. The hot air is cooled and in exchanger and is cooled in heat exchanger up to the atmospheric temperature. The cool air is then expanded in an expander. The temperature of the air coming out of the expander is below the atmospheric temperature due to isentropic expansion. The low temperature air coming out from the expander, it enters the evaporator and absorbs the heat. The cycle is then repeated again. The working of the air refrigeration cycle is represented on PV and TS diagram. The assumptions. Compression and expansion process are reversible processes. There is a perfect intercooling in the heat exchanger. There are no pressure losses in the system. These are the assumptions of air refrigeration systems. Applications of aircraft or air refrigeration system. External heat gain due to solar radiations. Heat is released by the occupants. Internal heat gain occurs due to electrical and mechanical equipment used. Types of air refrigeration. There are four different types of air refrigeration. They are simple, bootstrap, regenerative, and reduced ambient system. First, about simple air refrigeration. This is the diagram of a simple air refrigeration, and this is the TS diagram, that is temperature entropy diagram. In simple air refrigeration system, the compressed air after cooling is in air cooler is passed through a cooling turbine. The work of this turbine is to drive a fan which draws cooling air through the heat exchanger. The air then discharged from turbine at a pressure slightly above the cabin pressure. The fan is put on the downstream side, thus avoiding the additional temperature rise of the cooling air. This system is good for ground cooling since the fan driven by the turbine is a source of providing cooling air for the heat exchanger. However, the turbine work is not available for the compressor. Next about bootstrap air refrigeration system. In bootstrap is the TS diagram. In bootstrap air refrigeration system, two heat exchangers are present instead of one, and the expansion turbine it drives the compressor rather than a fan. Thus, it cannot be used for ground cooling. The primary purpose of the bootstrap system is to provide additional cooling capacity when the primary source of air it does not have a sufficiently high pressure to provide the amount of cooling required. The turbine drives the secondary compressor to raise the pressure of the primary air before it enters the turbine. It is used for high-speed aircraft where in the velocity of the air provides necessary airflow for the heat exchangers. As a result, a separate fan is not required. Next about regenerative air refrigeration system, and it is TS diagram. In regenerative system, it has two heat exchangers, but it does not require ram air for cooling as the air in the second heat exchanger. It's a modification of the simple system with the addition of a secondary heat exchanger in which the air from the primary heat exchanger is further cooled with a portion of the refrigerated air blend after expansion in the turbine, which is shown in the figure. It provides lower turbine discharge temperatures but at the expense of some weight and complications. Next about reduced ambient air refrigeration system and its TS diagram. In reduced ambient system, there are two expansion turbines, one in the cabin airstream and other in the cooling airstreams. Both turbines are connected to the shaft driving the fan which absorbs all the power. The turbine for the ram air operates from the pressure ratio made available by the ram air pressure. The cooling turbines it reduces the temperature of cooling air to level of static temperature to ambient air. Thus, primary compressed air it can be cooled to say T4 below the stagnation temperature T2 and a little above the static temperature T1. Thank you.